Section 5.2, we looked at multiplication of integers last time and some of the properties of multiplication. And then we have a few more things with multiplication that we're going to take a look at. Not a lot with division, but just a little bit, and then we will be finished. So this is where we are, Theorem 5.6. Theorem 5.6 says that for every integer a, if you take -1 times a, you get -a. And of course, you can read that equation from left to right or right to left. Right? That's what equations mean, that they work both directions. And so when we look at the right-hand side where it says -a, we understand that's being the additive inverse of a, right? Or the opposite sign of what a actually originally had. On Theorem 5.7, for all integers a and b, if you have -a times b, it's the same thing as having a times b with a negative in front. And if you have two negatives, that is -a and -b, then that's the same as having a times b. And then Theorem 5.8 is the distribution property. So a times the quantity b minus c would be ab minus ac. And then if you had it the other order, b minus c times the value a would be ba minus ca. All right, so let's take a look at some division stuff. Integer division. For all integers a and b, a divided by b is the unique integer c, if it exists, such that a equals b times c. We have seen this definition before when we did whole numbers. Basically the idea being that if you have a divided by b, hang on, I'm getting a little bit carried away with my stuff, divided by b, and it equals c, and you were to multiply both sides, for instance, by b, because that is the same as the opposite of dividing by b, then this would equal the b times c or c times b. And you guys do it with numbers all the time. The reason 6 divided by -2 is -3 is because 6 is equal to -2 times -3. Right? That's what it means to do division. We're just doing it now with the possibility of having negatives. When we look at divisibility, which we did back in Chapter 4, all of our stuff in Chapter 4 was divisibility for integers. And I think I said at least once in passing, it works for integers too. It doesn't work just for whole numbers, which is how we did it before. It works for integers too. And that's what this is saying. It says if a divided by b is a unique integer, then a is divisible by b. Equivalently, b divides a, or b, and then you've got the division sign, right? The divides by a, or divides a notation. So in other words, if you did, I'll use the same example I did just a minute ago, 6 divided by -2 is a unique integer, right? It's equal to -3. Then we could actually say that -2 divides 6. Remember, the notation is backwards. So when you do your test on Wednesday, you'll want to, or Friday, excuse me, you want to remember that, right? This is not a division bar like a fraction division bar. It is read -2 divides 6, is a divisor of or a factor of. Integer inequalities. For all integers a and b, a is less than b, written, a less than b, notation you're familiar with, if and only if there exists a positive integer k such that a plus k is equal to b. And we saw this again when we did whole numbers. The reason that this works, and I'll use integers that are not whole numbers just to show you that it works for them too. -2 is less than 1 because if I have -2, there is a number that I can add to it to get to 1. What would that number be in this case? 3. 3 would be that k value it's referring to. Okay, so we did that with whole numbers. It works with integers as well. Now, Theorem 5.9 is a little different. We haven't had this property at all before. For integers a and b, a is less than b, or equivalently, b is greater than a. If and only if b, actually have had this one, I'm thinking of the next one, I'm sorry. If and only if b minus a is equal to a positive integer, that is, b minus a is greater than 0. So I'll use the negative value or I'll use the value I just did before. -2 is less than 1 again. The reason that -2 is less than 1 is because if I subtract the larger one, or at least the one I'm saying is larger, 1, minus the smaller one, that is minus -2, I get some number, in this case 3, and that number I get, no matter what it is bigger than 0. Okay, when I do the subtraction of a larger integer minus a smaller integer, I have a positive value that I get back. We did have that one before. Looks like this got left out. For all integers x and, I'm sorry, x, y, and n. That's what should go right there in that blank. Yeah, for all integers x, y, and n, the following properties are true. You're say let x, y, and n be integers. Sorry. A little different, but same thing. Got integers, x, y, and n, they're integers, all right? If x is less than y, then x plus n is less than y plus n. We've seen that one before. That one's not new. The next one is, if x is less than y, then negative x is greater than negative y. And that's the one I was thinking of a moment ago. That's new, because we haven't had negative numbers before to talk about them this way. So imagine doing the same thing with the same values I gave you before. I had negative 2 is less than 1, and if you multiply them both by a negative, you get 2, and you get negative 1 over here. What direction does the inequality have to go to make the statement true? Well, it has to open to the left, right? 2 is bigger than negative 1. And that happens anytime you multiply by a negative in an inequality, as it switches the direction of the inequality. Occasionally I have someone ask me, why doesn't it happen with the equation? Well, because the equation's equal on both sides. There isn't a value that's bigger than the other value. So there's no need for anything to change because it's an equality versus an inequality. Okay, the next two are quite similar to the last one and to each other, actually. It says if x is less than y and n is positive, then x times n is less than y times n. In other words, as long as it's a positive number and you multiply on both sides, the direction of the inequality stays the same. Okay, so if I took this negative 2 is less than 1 and I multiplied it by 3, I'd get negative 6, I'd get positive 3. The inequality still is a less than inequality, right? Positive number does not change the direction of the equality. But the second one, or the last one on the screen, says that if you multiply it by negative, the inequality's direction will change. So let's try this now by negative 3. Well, what's negative 3 times negative 2? 6. And negative 3 times 1 is negative 3. Which value is bigger? 6. So the inequality has to open like this, and the direction of the inequality changed. So it's kind of like step number 4 up here is a combination of steps 2 and 3, right? Yeah, it is. All right, we have one last example. All right, let's take a look. I'll have 2 examples in one, I'm sorry. But it's the last example. It's just got a part A and part B. We'll say it that way. Okay, it says find all integers, if any, that make the following statement true. Now, the reality is that you might actually be able to look at a few of these and know the answer. That's okay, and if you do that, that's fine. Some of them you can't just see very easily, though, so I'm going to actually work them out with a little bit of algebra just in case you aren't good at seeing the answer in the form that it's in, okay? The other thing is that while it's true that for an equation, that is, these have equal signs, sometimes it's obvious what it is, you know, you've got your answer to be. But if I switched it to an inequality, you might be like, okay, but which one is it? Is it greater than, is it less than? I can't tell as easily. It's harder to make that decision, in which case the algebra helps you to make that decision too. So I'm going to work it out with the algebra, okay? All right, there's a couple of things we could do on example A. Can somebody give me a suggestion of what you would think to do first? Distribute. That is one option. So we could distribute the negative 5 through everything. Does anybody else have a different option that they might pursue? You could divide both sides by negative 5. Okay? So Lauren suggested the distribute first, so I'm going to do the distributing on this one. But if you want to divide both sides by negative 5, it's actually a quicker process. So if we multiply this through by the negative 5, I have negative 5x, and then what? Plus a 15, right? That's one of the properties of integers that's in this section, and it's still equal to the negative 5 over here. What's my next step? Subtract the 15, and that's the property from the last slide, actually, where I'm adding a value to both sides of the equation. It's going to stay an equation. I have a negative 5x on the left. What's going to be on the right? It's negative 20, right? Negative 5 and negative 15 is negative 20. And my last step would be to do what? Divide by negative 5. So if I had an inequality, this would change the direction, correct? I don't on this one, so of course it's just an equals sign. But what is now negative 20 divided by negative 5? 4. What do you think might be a good step to make sure that you got the right answer? Plug it in. So if we go back to the original problem, whether we write it down or whether we do it in our head, if I put a 4 in right here, what is 4 minus 3? 1. And what is 1 times negative 5? Negative 5. Okay. This one's a little bit trickier because it says squared, right? Now, I don't really think that what you want to do is to multiply this out. You probably don't. Probably looking and trying to decide if there's a number that will work might be easier. Maybe. So let's see. Is there a value that when you that when you subtract it for 1 or 1 minus it, that you get back the same thing? What do you suggest? No? You didn't have a suggestion? Sorry. What do you have? The number 1. So if I put in the number 1, what's 1 minus 1? 0. And 0 squared would be the same thing, 0. And I could do it in any order, right? So if I did 1 minus 1 squared here, because I put the 1 in for x, if I put the 1 in for x over here, I still have 1 minus 1, right? Squared. So this is 0 equals 0, and that's good to go. I'm good with that. But that's the only number that when I square it, that this will work. So for example, try the number, that may not be true, maybe 2 will work too. I don't think I wrote 2 down. Let's try the number 2. That's what I wrote down. I read my notes wrong. Okay, so let's try putting in the number 2 on this one. What happens if I put the number 2 in? Okay, but then I have to square them, right, Gretchen? Yeah, so if the left-hand side I get a positive 1 and then I square it. On the right-hand side I get a negative 1 and I square it. What happens? You get the same thing, right? You do. So 1 worked. So far we have the answer of 1, we have the answer of 2. 1 worked originally, 2. Try something else. They're all going to work. Why? Yeah, because what happens on the inside of this particular problem is that when I'm subtracting, I'm just subtracting them in reverse order. So it doesn't matter the order I subtract something in. Yeah, I mean it matters, right? Like if I do 5 minus 4 and I do 4 minus 5, I don't get the same thing. Agreed? I mean the order I subtract something in matters. What about this makes it not matter? Squaring. And what happens when you square things? Changes the signs to all be positive. This would be almost the same thing as if I had absolute values around both sides, right? If I had absolute value of x minus 1 and absolute value of 1 minus x, do I get the same thing? Yeah. So it's like saying, what's the distance between Shawnee and Midwest City? What's the distance between Midwest City and Shawnee? It's the same thing. So what do you suppose the answer should be for this particular problem? Yeah. And because we're working with integers, we're going to say all integers, but the reality is that, yes, it is all real numbers. But we're only working in the integer system, so it's all integers will work. Any integer you'd like. Okay, any questions on that? Let me show you what happens if you try the algebra for this really quick, and then we will finish up. So let's say, for instance, that you do the algebra for this, because you weren't sure about doing this sort of guessing and thinking about it the way we just sort of did out loud. That's okay, but you have to remember, and we haven't done a lot of algebra, that this means x minus 1 times x minus 1. And this means 1 minus x times 1 minus x. So what happens when I do x minus 1 times x minus 1? What do I have to do to do that? FOIL, distribute, whichever language it is you're most familiar with, you're going to multiply the x times x, that's x squared. The x times negative 1, that's negative x. On the inside, you're going to multiply the x times negative 1, that's negative x. Negative 1 times negative 1, that's 1. On the right-hand side, you're going to do the same thing, and you're going to end up with much the same thing. And if I simplify this, what do you notice? It is. It's the same thing. I'll put them in order just so it looks more obvious, but it's the same thing on both sides, isn't it? And probably somewhere in an algebra course somewhere somebody told you that if you got the same thing on both sides, then it shouldn't matter what x is, right? I mean, like I could subtract x squared off. I can subtract off the 1. I can add the 2x. Eventually, if I do all that, I'm going to get 0 equals 0 at the bottom. Fine. What does that mean? Well, it means that it didn't matter what x was. It worked out the same way on both sides no matter what. So it feels a little funny even if you look at it from that perspective, but it still works. All right.
So because you said that the parentheses x minus 1 parentheses squared is the same as having absolute value sign.
Well, the answer ends up being the same. Like if I did this, I'd also have all real numbers. Because this eliminates the positive negativeness of the difference, just like the squaring eliminates the positive negativeness of it.
Could you put the absolute value 1 minus x is equal to parentheses 1 minus x squared?
No, that's not the same thing. Yeah, the absolute values don't actually equal the thing squared. Just the net effect of it on what x can be is the same thing. Okay, so if the absolute values are the same, are in the problem like this, that's fine. This would be x is all real numbers. If the squareds are in the problem on both sides, that's fine. The answer is all real numbers. Good questions. Any others? All right.